Alright guys, in this extremely short video, I'm going to quickly go over what the terms LRAM and RRAM stand for, okay? In the previous video and in the example that you're currently seeing on the screen right now was when we went ahead and found basically where a particle can be at a given amount of time when the velocity is varying. And we use what was called the midpoint rectangle approximation method, okay? There is two other approximation methods. Now, you are not required to do all three when you are approximating these, okay? You sometimes get a little bit of freedom. Sometimes a question may tell you to specifically use LRAM, RRAM, and so on and so forth, or MRAM, okay? So there's not necessarily a requirement to do all three of them unless it asks for you to find out which one of the three is the best approximation there. So what I want to use in this video is a quick little time just to what it means to say LRAM, RRAM. So let me kind of write this down a little bit here. So for example, if you are given something that says, in this case, MRAM, okay? MRAM stands for the midpoint rectangle approximation method. On the other hand, you may see LRAM, which stands for the left hand rectangle approximation method, and then RRAM stands for your right hand rectangle approximation method, okay? And so when it says left hand or right hand, all this really means is that you are using the left end of the interval or the right end of the interval. So let's go back to our example up here. Each interval had a change of t of 1/4. If it asks to find an approximation of LRAM, instead of using the midpoint like we did with 1/8 and 3/8 and 5/8 of each of these intervals, you would just simply use 0 and 1/4 and 1/2 and 3/4 and then 1 and so on and so forth as you continue to go through all 12 of these intervals. If it asks you for the right hand, you would just use 1/4 and 1/2 and 3/4 and 1 and so on and so forth, and you would do the exact same concept. You would take each of those, using that instead of your midpoint, you would use those to substitute into v of t to find your height, and then you would multiply that height times 1/4, that height times 1/4, and then that height times 1/4, and so on and so forth, or whatever your change of t actually was, okay? So there's not necessarily one better than the other. I think from my experience, I've noticed that it's random as to when things are a little bit, I don't know, better than others. I think it's easier to obviously use an LRAM or an RRAM because you don't have to take that time to find the midpoints. I feel like from what I've noticed in my experience, that midpoint gives a little bit better approximation, but I can't say that's always true by any means, okay? And so once you find your LRAM heights, or areas, excuse me, you would add up all of those areas. Or if you found all of your RRAM areas, you would add up all of those and see roughly what you get and so on and so forth, okay? So I just kind of want to pinpoint exactly what we mean when we say LRAM versus RRAM and MRAM, okay? Alright guys, the next video will have another example that dives into a little bit more of application as to how can we look into estimating the volume of a sphere.